Okay, so good day everyone. So I am Renalyn Artubal and together with me are my group mates, Rodi J. Asilom and Regine Baldosa. So in this video, we will be discussing about analytic geometry. So when we say analytic geometry, it deals with the properties, behaviors, and solutions to points, lines, curves, angles, surfaces, and solids by means of algebraic methods in relation to a coordinate system. Hence, this branch of mathematics will tackle all about geometric figures as plotted on the rectangular coordinate system, otherwise known as the Cartesian coordinate system. So in this video, we will focus on the ordered pairs of real numbers, distance formula, slopes, parallel and perpendicular lines, and we also have conic sections. So let's have here first ordered pairs of real numbers. So the points in a plane can be identified with ordered pairs of real numbers. So we start by drawing two perpendicular coordinate lines that intersects at the origin O on each line. So as you can see here in figure 1, usually one line is horizontal with positive direction to the right and is called the x-axis. So please refer in the figure 1. So the other line is vertical with positive direction upward and is called the y-axis. So as shown in the first figure, there is a perpendicular line to the x and y axis, which is the point P. Then the point P is assigned the ordered pairs A and B. So the first number A is what we call the x coordinate of P. And then the second number, which is the B, is called the y coordinate of P. So this coordinate system is called the rectangular coordinate system or the Cartesian coordinate system in honor of the French mathematician René Descartes on 1596 to 1650. So the plane supplied with this coordinate system is called the coordinate plane or the Cartesian plane and is denoted by r squared. So the x and y axes are called the coordinate axes and divide the Cartesian plane into four quadrants, which are labeled quadrant 1, 2, 3, and 4 as you can see in figure 1 also. So now let's move on to distance formula. So to find the distance P sub 1 and P sub 2 between any two points, P sub 1, x sub 1, y sub 1, and in P sub 2, which is quantity x sub 2 and y sub 2, we note the triangle P sub 1, P sub 2, and P sub 3 in figure 4. So please see here in figure 4 we have P sub 1, P sub 2, and also P sub 3. So these 3 points form a right triangle. So by the Pythagorean theorem, we have P sub 1 and P sub 2 is equals to square root of P sub 1 times P sub 2 squared plus P sub 2 times P sub 3 squared. So we have a distance formula between the points P sub 1, quantity x sub 1, y sub 1, and P sub 2, quantity x sub 2, y sub 2 is we have the P sub 1 times P sub 2, or we have D is equals to the square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. So the distance formula is P sub 1 times P sub 2, or commonly we will write it D. So we have D is equals to square root of x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. So for the next part or for the next topic, we have my group mates, which is Regine Baldoza, to explain to you the lines, slope of a line.
Good morning, everyone. So, have you ever wondered how we measure the steepness of a road or the incline of a route? Well, it all comes down to the concept of slope. So, the slope is a measure of the steepness of a line. So, when we say steepness of a line, it is the ratio of a change in vertical distance to the change in horizontal distance. So, it tells us how much a line rises or falls as we move from one point to another. So, the slope of a non-vertical line that passes through the points P sub 1 with pair coordinate x sub 1 and y sub 1 and point P sub 2 with pair coordinate x sub 2 and y sub 2 can be measured using this formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this formula takes 2 points on the plate. The points x sub 1, y sub 1, and x sub 2, y sub 2, and finds the ratio of a vertical change or raise to the horizontal change or the run. Now, here's something interesting. The slope of a vertical line is actually undefined or not defined. It is because the denominator in our formula, x sub 2 minus x sub 1, becomes 0. And dividing by 0 is not possible in mathematics, meaning it's undefined. To find the equation of a line, we use its slope, which is a measure of the steepness of a line. So the slope is therefore the rate of change of y with respect to x. One important thing to remember about slope, the fact that if the line is straight means that the rate of change is constant. That means the rate of change between any 2 points on the line is always the same. So imagine climbing a staircase. If each step is of equal height in width, the steepness remains constant. That's exactly how straight line slope works. Point slope form of the equation of a line. This form is useful when you know a point on the line and its slope. An equation of a line passing through the point P sub 1, x and y sub 1 and having slope m is y minus y sub 1 equals m multiplied by x minus x sub 1. Here, x sub 1 and y sub 1 represents a known point on the plane, and m is the slope. By substituting these values, we can find the equation of any line. Now, here's another widely used form, the slope-intercept form of the equation of a line. An equation of a line with slope m and y-intercept is y equals m multiplied by m plus b. So in this equation, m is the slope and b is the y-intercept. Y-intercept is where the point of the line crosses the y-axis. So lines can also be horizontal and vertical. As you can see in the figure below, if a line is horizontal, the slope is m equals 0. So its equation is y equals b, where b is the y-intercept. On the other hand, a vertical line does not have a slope, but we can write its equation as x equals a, where a is the x-intercept because the x-coordinate of every point on the line is a. So in this equation, m is the slope and b is the y-intercept. Y-intercept is where the point of the line crosses the y-axis. So lines can also be horizontal and vertical. As you can see in the figure below, if a line is horizontal, the slope is m equals 0. So its equation is y equals b, where b is the y-intercept. On the other hand, a vertical line does not have a slope, but we can write its equation as x equals a, where a is the x-intercept because the x-coordinate of every point on the line is a. Parallel and perpendicular lines. First, let's talk about parallel lines. Two non-vertical lines are parallel if and only if they have the same slope. This means they will never intersect no matter how far they extend, as you can see in the left figure below. So think of railroad tracks. No matter how long they stretch, they remain side by side without crossing. Now let's move on to perpendicular lines. Two lines with slope m sub 1 and m sub 2 are perpendicular if and only if m sub 1 and m sub 2 is equal to negative 1. That is, their slopes are negative reciprocals. M sub 2 is equal to negative 1 over m sub 1. So this means that perpendicular lines always intersect at a 90-degree angle, just like the corner of a square, or as you can see here in the right figure below.
Today, we will explore the fascinating world of the conic sections. So these are curves obtained by the intersection of a plane and a double nap cone. The main types will cover the hyperbolas, ellipses, parabolas, and circles. So let's talk about the circle. So a circle is defined by the set of all points P whose distance from a fixed point, the center, and the constant radius r. So the key property, the standard equation of a circle with center C, H and K, the radius is r, is being shown in the illustration. So if the center is the origin 0 and 0, so the equation simplifies x squared plus y squared is equal to r squared. So the importance of this one, circles play a crucial role in various fields like engineering, architecture, and even nature like the planetary shapes. Okay, let us move on for the parabola. So a parabola is defined as the set of points in a plane that are equidistant from a fixed point, the focus, and a fixed line, the directrix. So the vertex of the parabola lies halfway between the focus and the directrix. So the equation, the general form of the parabola can be expressed as y is equal to ax squared. Okay, the visualization, okay, please refer to the paragraph illustrating the parabola, the focus, and the directrix. So it is just being shown in the illustration. Now, let's talk about the importance of the parabola. So parabolas are found again. Parabolas are foundational in physics for projectile motion and design of the satellite dishes which focus signals. So now let us move on to the ellipses. So an ellipse is the set of points in a plane where the sum of distances from two fixed points f1 and f2 is constant. So the fixed 2 points are known as the foci of the ellipse. A notable example is the Kepler's law, which states that the orbits of the planets in our solar system are elliptical with the sun at one focus. Okay, the standard form of an ellipse is x squared is equal all over a squared plus y squared all over b squared is equal to 1. Now let us move on for the hyperbola. So a hyperbola is defined as the set of all points in a plane where the difference of distances from fixed points, the two fixed points, the foci f1 and f2 is constant. So the hyperbola's characteristic is similar to that one ellipse, of an ellipse I mean. However, instead of a sum of distances, we use a difference of distances. So the standard form of hyperbola is given by x squared all over a squared minus y squared all over b squared is equal to 1. So p is on the hyperbola when, okay, you can refer to the figure number 23. So conic sections form a fundamental aspect of algebra and geometry, deeply connected to the natural world and applications in science and technology. They emerge from the intersection of a plane and a double nap cone, providing insights into the characteristic of curves and shapes essential for solving various practical problems. So that's all for this morning, and thank you so much for listening.